I got started as a kid in chemistry because I love colors. I love to look at colors of compounds and try to figure out why some of them were red, some of them were green, some were blue, some had copper in them, some had chromium. And when I was a kid, I had my own lab and made lots of colored compounds. They were really fascinating, and I got hooked on chemistry. Chemistry really fascinated me. I wanted to know what these colors were, how the colors were generated by these compounds. And it wasn't until I went to college and studied chemistry and studied theory that I figured out what the colors were due to. And this was a tremendous experience for me to finally understand what the colors were due to. And I went on in my career to study structures of molecules, of transition metal complexes that had beautiful colors, things like the ruby. Rubies are red because they have chromium in them in a certain structure, and Prussian blue is beautiful because of an iron cyanide structure. Just on and on and on. I loved colors, and I loved to relate color to structure. And in my research work, I decided I wanted to figure out why biological compounds were colored as they are. Hemoglobin, red blood, blue blood, which is called hemocyanin, red-purple blood, which is called hemerythrin, beautiful blue copper proteins that are in bacterial systems. I figured out what the structures of these systems were and how their colors were related to their structures. And what I'm doing now is applying all this work to try to work on the solar energy problem. The world is in dire straits now because we're running out of oil and gas and coal. We have a tremendous problem with carbon dioxide evolution, and so we must find a way to solve this problem. We must find a way to have energy in this world, energy on this planet that's environmentally safe. And so solar energy is my current interest. And I'm working with molecules like the one I'm showing you here. This is a ruthenium complex, which we can put on the surface of titanium dioxide to make solar cells, to make what we call dye-sensitized solar cells. These solar cells we can make now with reasonable efficiencies, and they make electricity out of sunlight. We're trying to make them now so they will mimic photosynthesis and help us with the world's energy problem. I think I encourage those of you who are listening to this little talk, I encourage you to look into chemistry, to go into chemistry, to study chemistry, to maybe go to Lahore and study chemistry. I think you'll find your teachers very exciting and wonderful people, and I encourage you to explore your interest. And more than anything else, what you should do is to go into something you really love to do. Make sure you're really excited about it and you love it, and you can do it 7 days a week, that you don't want to go home. You want to keep working on it. If you find that subject that you really love, my advice, go into it, love it, help us out. We need more scientists on this planet. We need them now in this century, and I hope you'll have fun with it. Thank you.